Good day, I'm Carlo Jude Veloso, NC student from Mapua Institute of Technology. I'm here to present my research paper about photocatalyst, an enhancement to UV radiation. For my introduction, the world is composed of 70% of water. The water is categorized as fresh water and the salt water. The percentage of fresh water is just 2.5% from 97.5% salt water, wherein 69% of the fresh water is at the glaciers. If we look at it, 31% fresh water available is being shared by 7.9 billion people and billions more of animals. In a very small amount of source of water, the scarcity of water is growing, especially with continuous growth of population in cities. Water is very essential for life on Earth. It is not only the source we should put in mind, but from getting water, but also the process on distributing it to the consumer, particularly to people. There are people getting sick or even die from drinking water because of no proper sanitation applied to it. Different processes are now discovered or invented to help in improving the quality of water provided to the people, and even salt water is now treated to become another source of drinking water. One of the most vital parts in water treatment process is the disinfection. One of the capable techniques of disinfection is through using the UV radiation. What is UV radiation? Ultraviolet radiation uses a short wavelength to kill microorganisms. The UV radiation targets the nucleic acid of the microorganisms that destroys their DNA, causing them not to be able to perform their vital cellular function, such as prohibiting growth and reproduction. The first use of UV radiation for drinking water was at the US at the year 1960. Continuous research in UV radiation field all over the years led to more economical cost and new methods are made. This also led to create standards and regulation for using the UVGI or ultraviolet germicidal irradiation is designed for the exposure of environment such as the raw water to germicidal UV. The germicidal UV has a wavelength shorter than the visible light with a wavelength of 2537 angstrom or 254 nanometer. To be able to disinfect the water, it needs a force to create a flow of water to pass through the germicidal lamps that exposes to the germicidal UV. The effectiveness of the UV radiation is based from the length of time of exposure of the microorganism to the UV, the turbidity of the water, and the characteristic of the microorganism to withstand the UV radiation. In some system, uses a redundancy of exposure of microorganisms to UV through circulating it. It uses redundancy ensures the effectiveness to microorganisms that are resistant to it. And so, what is photocatalyst? The photocatalyst is a process of accelerating the photoreaction in the presence of catalyst. The photocatalytic activity depends on the ability of the catalyst to create electron-hole pairs, which generates free radicals. The application was discovered by means of water electrolysis by means of titanium dioxide. One of these newfound effects was photocatalytic oxidation, which accelerated the formation of hydroxyl radical, one of the strongest oxidizing agents created by nature. Using energy found in the UV light, photocatalyst titanium dioxide could break down numerous organic substances such as oil grime and hydrocarbons from car exhaust and industrial smog, volatile compounds found in various building materials and furniture, organic growth such as fungus and mildew. So how could photocatalyst provides us health benefits? The photocatalyst titanium dioxide is capable of giving an effect or destruction to bacteria and viruses due to the formation of hydroxyl radical when it is exposed to light. The titanium dioxide absorbs the light, which causes a synergenic system that would release the hydroxyl radical. The hydroxyl radical is predominant species involved in the bactericide and virucidal action of photocatalyst. The hydroxyl radical, having an extremely short duration, must be generated in the vicinity of the membrane to be able to remove the compounds. It is extremely short lifespan being produced on a surface make it harmless to people. The design of the advanced oxidation are based from the generation of hydroxyl radicals. Considering the effects of hydroxyl radicals, it is known to be a very powerful oxidizing agent due to its characteristics as a strong oxidizing capacity, and the catalyst can be utilized for sanitation, deodorize, and purify water. The recent research shows different application of photocatalyst for disinfection and targeting different pathogenic microorganisms. Indeed, photocatalyst has been reported to be effective against a wide range of microorganisms such as bacteria, viruses, and protozoa. Photocatalysis not only kills cells of bacteria but decomposes them. It has been seen that titanium dioxide is more effective than any other antibacterial agent because the photocatalytic reaction takes place even when there are cells that cover the surface and multiplication of bacteria is active. It becomes active on the surface by passing the biofilm created by bacteria. It is therefore effective where traditional chemical sanitizing agents achieve fewer results. In addition, endotoxin derived from the death of the cells is decomposed by photocatalytic action. Titanium dioxide does not decompose and shows an antibacterial and virucide long-term effect. In general, disinfection with titanium dioxide is 3 times more effective than what you achieve with chlorine and 1.5 times percent more effective than ozone. As said earlier, there are factors that affect the effectiveness of the photocatalytic action. The first is titanium dioxide loading. There are different parameters to be considered in using photocatalyst. First, the titanium dioxide loading. The concentration of titanium dioxide loading in the photocatalytic water treatment system affects the overall photocatalysis reaction rate in a true heterogeneous catalytic, where the amount of titanium dioxide is directly proportional to the overall photocatalytic action rate. When the amount of titanium dioxide increases above the saturation level, which lead to a high turbidity state, the light photon absorbs coefficient efficient usually decreases. The excess titanium dioxide particles can create a light screening effect that could reduce the surface area of titanium dioxide being exposed to light illumination and the photocatalytic efficiency. Therefore, any chosen photoreactor should be operated below saturation level of titanium dioxide catalyst used to avoid excess catalyst and ensure efficient photons absorbed. In this sense, both catalyst loading and light scattering effect can be considered as function of optical path length in the reactor. Second, the pH. In heterogeneous photocatalytic water system, pH is one of the most operating parameters that affect the charge on the catalyst particle size of catalyst aggregates, and positions of conductance and valence bands. Due to the nature of titanium dioxide catalyst use, any variation in the operating pH is known to affect the isoelectric point or the surface charge of the photocatalyst used. Many reports use the point of zero charge or PZC of titanium dioxide to study the pH impact on the photocatalytic oxidation performance. The PZC is a condition where the surface charge of titanium dioxide is zero or neutral that lies in the pH range of 4.5 to 7, depending on the catalyst used. A similar electrostatic interaction enhancement for photodisinfection of microorganisms was used during photocatalytic process. During the photodisinfection, the initial photo-induced damage to the microorganism takes place in the lipopolysaccharide layer of the external cell wall and on the peptoglycan layer. This followed by lipid membrane peroxidation and the subsequent oxidation of the membrane protein and polysaccharides. An increased density of titanium dioxide during at low pH can perform electrostatic link and the bacteria of negatively charged surfaces, resulting in an increase of photodisinfection. Observed that the bacterial inactivation rate was enhanced at pH of 5. It should be noted that the enhanced bactericidal activity of titanium dioxide at a low pH is due solely to the titanium dioxide immediately photokilling and not acidification of the cell. The negligible E. coli reaction to acid condition was the presence of an acid tolerance response to the bacterium itself, which secreted acid-induced proteins and acid shock protection. However, it did not find any difference in E. coli inactivation rates when the initial pH between 4 and 9. To date, various types of microorganisms have been successfully inactivated during titanium dioxide photocatalysis, which include Lactobacillus acidophilus, E. coli, Saccharomyces cerevisiae, Cholera vulgaris, Streptococcus faecalis, and aureus, Enterobacter glaucae, total coliform, Candida albicans, Fusarium solami, Aspergus niger, and others. The third is the temperature. Up to date, there is no thorough study with regards to the effect of photocatalyst to each microorganism under different temperature. Thus, the photodisinfection using titanium dioxide catalyst is usually conducted below ambient temperature of 80 degrees Celsius to prevent high water heating cost because of high heat capacity. Fourth, the dissolved oxygen. The dissolved oxygen has significant role in photodisinfection. The dissolved oxygen causes promotion of microbial growth and thus it prolongs the irradiation time. It does recommend that the effect of the dissolved oxygen on the microbial inactivation should be investigated thoroughly, in particular photoreactor system before improvising the dissolved oxygen sparging strategy. The fifth is the wavelength. The UVA range has its light wavelength spans from 315 to 400 nanometer, while UVB has a wavelength range of 280 to 350 nanometer, and the germicidal UVC range from 100 to 280 nanometer. In most of the previous studies, the UVA light provides light protons sufficient for photonic activation of the catalyst. As with outer, outdoor solar irradiation, the UVC is usually absorbed by the atmosphere and not reaching the Earth's surface. Only the lamp-driven photoreactor can utilize UVC irradiation sufficient artificially for photonic activation of catalyst and reduction of variable microorganisms. The mechanism of UVC cell destruction involves direct induction of pyrimidine and purine and pyrimidine abducts on the cell DNA. However, not all microorganisms are susceptible to UVC radiation, and some highly resistant microorganisms can survive through disinfection process. These include Legionella pulmonophila and Cryptosporidium parvum oxys. 6. The turbidity often refers to insoluble particles that are present in the targeted water. The presence of such insoluble particle matters are highly detrimental to titanium dioxide photocatalyst based process as they are affected the optical properties and further impede the penetration of UV light by strong scattering and absorption of the rays. Also, excessive levels of turbidity can reduce both photomineralization and disinfection efficiency of the pollutants that are present in water, owing to shield the effects that attenuate the light penetration whose pollutants to flee from the treatment. Suspended solids will also shield target pollutants from oxidation reaction. All these factors ultimately decrease the overall photocatalytic efficiency of water treatment. To ensure rapid photocatalytic reaction rate, turbidity of the targeted water should be kept below 5 NTU for optimal UV light utilization and photocatalytic reaction. It was observed that the water turbidity higher than 30 NTU will negatively affect the rate of photocatalytic disinfection. And lastly, heavy metals and noble metals. To treat such metals, titanium dioxide photocatalytic process has been simultaneously convert these metals into non-toxic ionic states and further reduce them into their corresponding elemental form on titanium dioxide surface for metal recovery. So how could photocatalyst affect for economical benefits? The application of photocatalyst, particularly the titanium dioxide, for water treatment could be beneficiary for countries and communities that aren't able to install water treatment facility. The people living in rural areas are usually not supplied with water coming from water treatment facilities. The promotion of water disinfection or the SODIs are usually required to areas not capable of for infrastructure for water treatment plant and with lack of good quality of water supply. The downside of SODIs is the water capacity it can hold. The SODIs has a limit of 2 liters only and at least 48 hours of exposure. A research shown by placing a flexible stick coated with titanium dioxide could produce 20 to 25% more efficiency on inactivating E. coli than sodium alone. It could also reduce the concentration of Cryptosporidium parvumosis present. The saltwater is fully autonomous solar reactor system to drinking water purification in remote locations without any chemical addition. Scientific and technological requirement developments will be based on photocatalytic generation by using sunlight of hydroxyl radicals and singlet oxygen species to respectively detoxify and disinfect contaminated and trace level of drinking water, and promoting period of disinfection and process is about 6 hours. The photocatalyst will be able to conserve more energy on and water treatment facility since it could disinfect greater than the UV radiation alone. True photocatalyst requires screening before treated because of the quality of the required turbidity level to have an efficient disinfection. The amount of float passing through is also greater. This will improve the output supply of water by the water treatment facility. To summarize my research paper, I have concluded that the current demand for water is currently increasing proportional to the increase of the population. Investment for water supply are one of the goals in the world economy today. Creating different technologies and methods for treating different qualities of water are being proposed. The sun has been the unlimited and constant source of renewable power supply. It could also be the key for disinfection of pathogens found in the water. The UVC, which has been an equivalent that cause destruction of DNA of a microorganism. To increase the effectiveness of UV irradiation, a photocatalyst is added. The photocatalyst titanium dioxide enables to release hydroxyl radicals whenever it is exposed to UV radiation. The hydroxyl radical has been effective agent against pathogenic microorganisms. Apparently, the hydroxyl radical has a short lifespan, making it harmless to humans. We intake the disinfected water through photocatalyst of titanium dioxide. Through the distinct characteristic of UV radiation and photocatalyst, different methods or processes are being researched to increase the effectiveness and field of application. In terms of application, the photocatalyst could be reliable for source of treating water, especially for rural areas. The water treatment facility could upgrade their disinfection system by applying the photocatalyst and could help to decrease the energy consumption but increasing their output. The study for photocatalyst still has a lot of potential application and could one day change the system of water treatment.